Hello everyone. So today we are going to see an important topic in deep learning, that is dropout regularization technique. So deep learning uses too much data for training and too much parameters. But when there is a limited data, overfitting can occur. So to reduce the overfitting and improve generalization, dropout regularization technique is used. So let's see the technique in detail. So, deep learning models can overfit when trained excessively on available data. Overfitting causes the model to perform well on training data but poorly on unseen data. So, overfitting can cause the model to perform poorly on the data which is other than the training data. So, this dropout regularization technique is introduced to overcome this issue by preventing the neurons from relying too heavily on the specific patterns. So basically, in the dropout regularization technique, we made the neuron independent of each other or independent of each other's behaviors to overcome overfitting. It improves the generalization capability of neural networks by introducing randomness during training. So, as you can see in this diagram, in the first in the first part of the diagram, the dropout regularization isn't applied, and then after applying the dropout regularization, these three neurons are dropped out so to reduce the complexity and improve the generalization. So what exactly dropout regularization means? Let's see the concept of this technique. Dropout randomly, as the word suggests, dropout randomly drops out or ignores a portion of neurons during training. So this dropout technique to the neurons is applied to the hidden and input layers, usually not the output layer, because it will cause more to the model's performance. Each neuron is temporarily removed with a certain probability dropout rate. So we can predefine this dropout rate as 0.2, 0.3, and for that rate, the neuron is removed from the layers. The remaining active neurons are scaled up to maintain the output consistency. So to maintain the overall output and model's performance, the uh, remaining neurons are scaled up. This helps the network become less sensitive to specific neuron weights, improving robustness. So this dropout improves the robustness in the model's performance and encourages independent feature learning. So it makes the neurons independent of each other's behaviors. For example, if the dropout rate is 50%, then half of the neurons will be disabled in each layer or in each hidden layer. Now, let's see how this dropout mechanism exactly works. So during each training iterations, a subset of neurons from any layer is randomly deactivated along with their connections. So the neurons that are going to deactivate are randomly selected. The network learns to adapt without relying on specific neurons. So because of this random deactivation of neurons, the other neurons become independent or become like they don't rely on the network. This process resembles training multiple smaller networks simultaneously. At inference time, all neurons are active, but their outputs are scaled to account for dropout. So for implementation in the Keras library, we use the code as tf.keras.layers.dropout and we give the rate value as 0.2, 0.3. And in PyTorch, torch.nn dropout p is the code for implementing the dropout technique, regularization technique. So let's see the working mechanism through this diagram. The network will drop out during a single forward pass. Then nodes set to 0 during the forward passes. These nodes that are showed with light color are set to 0. That means these nodes are dropped out from the output. Like the output of these nodes will not be considered in the overall output of the model. Dropout is the equivalent of training several independent smaller networks on the same task. The final model is like an ensemble of smaller networks. Like these networks act as a smaller networks, reducing the complexity and reducing the overfitting. So this reduces variance and provide more robust predictions. For testing and inference, we use the entire network, but for training, we use only the neurons that are not dropped out during the forward pass. So this is about the dropout regularization's working mechanism. So in this regularization technique, there are some limitations, challenges, or you can say some disadvantages. As the data increases, this can cause a longer training time. Like random deactivation increases the training duration. Due to the random deactivation of neurons, the training duration increases. Then it is hard to interpret why dropout works in all cases. That this is a technique, it acts like black box. We can't interpret that why this dropout will work or why the dropout of that neurons will work. Then it requires careful adjustment of dropout rate and learning rate, sometimes redundant when batch normalization and dropout regularization both are simultaneously used. Then it can cause problems in the model performance. Then it adds layers and hyperparameters, increasing the design complexity of the model. So about this dropout regularization technique, in summary, we can say this technique is used to prevent overfitting by randomly disabling neurons during training, and this improves generalization and dependency of neurons on each other and on network. It promotes robust feature learning and acts as an ensemble of multiple subnetworks. Typical dropout rates range from 20% to 50%. Though it adds training time and complexity, dropout remains one of the most effective regularization technique for deep learning. So, dropout regularization is the most effective regularization technique and widely used regularization technique in deep learning. Also, there are other regularization methods which are L1, L2 regularization, early stopping, weight decay, and batch normalization. These are also the techniques that are used for regularization in deep learning. That's all about the dropout regularization technique. Thank you.